So it turns out that thinking about area between curves as just subtracting one region from another is not the most useful way to think about area between curves. There's a much more useful way of thinking about the problem, so let me just show you what it is. Let's go back to the problem of area under curves. Now, if you've watched the video on what goes into an integral, and I hope you have, what you'll realize is that when you integrate to find area under a curve, what you're really doing is finding the height of a typical rectangle, giving that rectangle a width dx, and you're just adding up all such typical rectangles. Again, if you don't recognize the term typical rectangle or representative rectangle, you should go back to the video on what goes into an integral. But what you'll see is that here, if I want to find the area under the curve y equals x squared plus 1, this curve has a height over the x-axis of x squared plus 1. So the blue rectangle for any given point x has a height of x squared plus 1, and we always give it a width of dx. So what you see after the integral sign is the height of the rectangle times its width, giving the area of just one typical rectangle. So that's what goes into an integral. We can think of area between curves in the same way. Let's suppose that what we want to do is we want to find the area between y equals x squared plus 1, and that's this curve up here, and the curve, well, not the curve really, the line y equals negative x, which is the purple line on the bottom. And we want to find that area on the interval 0 to 2. What we need to do is find the height of one typical rectangle that runs between those two curves. So I've drawn that in here in this diagram. You can see that the blue rectangle is what we would call a typical rectangle, and we simply have to find its height. Now note that if I pick some arbitrary point x on the x-axis, that's there, then the point on the blue curve that lies directly above that point x is going to have coordinates x squared plus 1. And if I instead pick the point that's directly below it on the line y equals negative x, that point is going to have the coordinates x comma negative x. So you can see that if I just draw this, just draw the top and bottom out to here, what you can see is that the height of this rectangle, in other words the vertical distance between the two curves, is just going to be x squared plus 1 on the top minus negative x on the bottom. And that in fact gives us, that's generally how you find the vertical distance between two things where you know one of them is on top and one of them is on the bottom, is you take the top value and you subtract the bottom value. The nice thing about this, I'll show you in a minute, it doesn't really matter where on the plane these points lie. It doesn't matter if they're above the x-axis, below the x-axis, if these are positive numbers or negative numbers. As long as you take top minus bottom, what you're going to get is a positive number that gives you the vertical distance between the two. So you can see is that we have here, for this typical rectangle, its width is still going to be dx, and its height is x squared plus 1 minus x. So what we need to do is to recall that what we want to find is the area between these two curves on the interval 0 to 2. We can set up the integral this way. It's going to be the integral from 0 to 2 of x squared plus 1 minus negative x, we'll put some brackets around that, and dx. So once again, this is the height of the blue rectangle. This is its width, and this is going to be the area of one typical rectangle. And of course, the integral just adds up all of those rectangles to get the full area under the curve. So we just skipped over a whole bunch of algebra, and I just that's the answer. The area between these curves is 20 over 3. I just want to show you something that I told you I'd show you that it doesn't matter where on the plane these curves lie, as long as you subtract top minus bottom, you're always going to get a positive number, and that's important because of course area is always a positive number, and you want to get the positive, so you want to get the positive number that gives you the height of the rectangle. I put up a very simple example here. What you can see is that if I take the lines y equals -2 and y equals -5, it shouldn't surprise you that the distance between them is equal to 3. I can calculate that just by doing -2 minus -5. That simplifies to -2 plus 5, which equals +3, giving the positive distance, the positive vertical distance between these two lines, even though both of them are actually below the x-axis and are negative numbers. So that's important. Just always to find the height of the rectangle, you're just going to subtract top minus bottom. So it's going to be your turn. I'm going to put up this set of curves and I'll ask you some questions about them.